Synovial joints are definitely the most complex type of joint that our body has, and this was obvious when we talked about the different movements that this type of joint can perform. On this learning outcome, which is learning outcome number 6, we will be covering the different types of synovial joints. Although all synovial joints share many common characteristics, like having a synovial cavity with a synovial fluid, for example, the shapes of the articulating surfaces they will vary, and this is what allows our body to produce many types of movements. In most joint movements, one bone will always remain in a fixed position while the other moves around an axis. And there are 6 categories in which the synovial joints are divided into based on the type of movement. They are the plane or planar joint, the hinge joint, the pivot, the condyloid or condylar joint, the saddle joint, and the ball socket joint. So let's talk about each of them in the next few slides. Before we move on, we can talk about how we classified a joint based on its motion. So there are 3 different types of motion, and this will have to do within how many planes this joint will move. Therefore, if it moves in one plane, it's going to be called monoaxial. So one plane means that it will just go back and forth in the same axis. The biaxial means that it will move in 2 planes, as bi means 2. Therefore, you can see over here that it's moving in 2 different planes. In triaxial, where tri means 3, you can see how this joint will move in 3 different directions. Another thing to keep in mind that the monoaxial can also be called uniaxial. So just keep that in mind. The articulating surfaces of bones in a plane joint or planar joint, which can also be called a gliding joint, they're going to be flat or slightly curved. And the plane joints, they primarily permit a back and forth or side-to-side movement between the flat surfaces of bones, but they may also rotate against one another. Many plane joints are going to be biaxial, meaning that they permit movement in 2 axes, like we see over here. Now, if the plane joint also rotates in addition to sliding back and forth, then they are triaxial, which will permit a movement in 3 axes. Some examples of plane joints are going to be the intercarpal joints, which are the joints between the carpal bones at the wrist, the intertarsal joints, which are the joints between the tarsal bones at the ankle, as we can see here on this image. We also have the sternoclavicular joint, which is the joint between the manubrium of the sternum and the clavicle, and the acromioclavicular joint, which is the joint between the acromion of the scapula and the clavicle. And these are just some of the main examples. Next, we have what we call a hinge joint, which is going to be made of a convex surface of one bone that fits into a concave surface of another bone, as we can see right over here on this image. For me, it reminds me like a door hinge where you open and close a door. It's going to be the same type of joint. Hinge joints are going to be uniaxial or monoaxial because they typically allow motion around a single axis, as we can see right over here, and therefore they're going to mainly permit flexion and extension. Examples of hinge joints are going to be the knee, the elbow, the ankle, and the interphalangeal joints, which are the joints between the phalanges of the fingers and the toes. Here we have the pivot joint, which is going to be formed by either a rounded, in the case of the head of the radius, or a pointed surface in the case, for example, of the dens of the axis. In the example shown here on the right, you're going to see how the head of the radius is going to be articulating with the ulna, in this case, the radial notch of the ulnar, and the other structure will be the ligament. In this case, this ligament is called the annular ligament, which holds the head of the radius in place. If you want to be a little bit more specific, we can say that the head of the radius will be articulating with the radial notch of the ulna that is held together by the annular ligament forming a pivot joint. And this type of joint will produce a movement that is going to rotate in its own longitudinal axis in one plane. Therefore, it will be considered a uniaxial type of joint or a monoaxial type of joint. And when the head of the radius will rotate within this axis over here, it will perform what we call supination and pronation, which we will talk more about later on still in this module. The same thing occurs with the joint between the axis and the atlas, as you can see over here. So there is also going to be a ligament, which is called a transverse ligament, which will hold the dens in place right over here, and it will allow the atlas to rotate on top of the axis. And this type of movement permits the head to turn from side to side when you shake your head no. The condyloid or ellipsoid joint can also be called condylar joint. It will be formed by this convex oval-shaped projection of one bone that will articulate with an oval-shaped depression on another bone, like a fossa. And as you can see, it will be able to move in two planes. Therefore, it will be considered a biaxial joint. An example will be the articulation between the radius and the two carpal bones it articulates with, as we can see right over here, which are the scaphoid and the lunate. And this will produce flexion and extension, or abduction and adduction, in addition to circumduction. Remember that circumduction is a movement that is performed by uniting several different movements. Another example is your metacarpophalangeal joints right over here, which is the joint between the metacarpal and the proximal phalanx. It can also be with regards to the tarsals on the foot. So it would be your metatarsals with your proximal phalanx as well of the foot. A saddle joint, it looks just like a horse's saddle with a rider on top, and that's why it's called a saddle joint. And it's the one that's represented here on this figure. And this movement of a saddle joint, it's going to be the same as the movements observed in the condylar or ellipsoidal joint. Therefore, it will perform either flexion and extension or abduction and adduction in addition to circumduction. And the example of a saddle joint is the one between the trapezium and the metacarpal one, which is the metacarpal of the thumb. Therefore, this type of joint is also a biaxial joint. Lastly, we have what we call a ball and socket joint, which will consist of this ball-like surface of one bone that will be fitting into a cup-like depression of another bone. These joints they're going to be triaxial, meaning that they will permit the movement around three different axes. Therefore, it can perform flexion, extension, abduction, adduction, and rotation. Examples of the ball and socket joints are going to be the shoulder and the hip joint. At the shoulder joint, the head of the humerus is the one that will fit into the glenoid cavity of the scapula. And at the hip joint, as we can see over here, the head of the femur will fit into the acetabulum of the coxal bone.